Hello guys, this video is about rate of change. We will be studying three types of rate of change questions. Now in this video, I will just mention the first type. So what are we going to face in the first type? So we will be seeing dy over dx or dy over dt a lot in this topic. If we see dy over dx, which means we differentiate the function with respect to x, right? We studied this in implicit equation already. The derivative of y is dy times y prime, which means dy over dx, right? Y prime means dy over dx. And equals, we differentiate right side to x. We do not write x prime because remember x prime means dx over dx. Since it is 0, 1, we don't write x prime here. So when you differentiate with respect to x, derivative of x will not have x prime because it is 1, so we do not write it. So what if we differentiate a function with respect to t, a third variable? So in this case, we differentiate both sides, so derivative of y becomes dy times 2y times y prime means dy over dt, derivative of y with respect to t, and differentiate right side. The derivative of right side is 2x times x prime this time. X prime represents dx over dt, derivative of x with respect to t. Okay, what if we differentiate both sides with respect to t and one of the variables is t? So in this case, the left side derivative is 2y y prime is dy over dt. The right side derivative, t squared, becomes 2t times, we do not have t prime because here we have t prime dt over dt. We have function t, we differentiate it with respect to t, just like dx over dx. We do not have t prime because it's 1. So in a nutshell, we can say if the denominator, the variable in the denominator is same as the variable in the function, then we do not write the prime. But here also the same, dt here, the function is t, we did not write t prime. We did not write x prime here, but this is the variable in the denominator. In the function we have y, so we write y prime. In the function we have x, we write x prime. So these two, x and y, are different than the variable in the denominator, so we write their primes. If they are same, we do not write. They are same, we do not write their prime, okay, because they gave you 1. So when you know this idea, you can solve every type of question. All questions are based on knowing this information. Let's start solving questions. First question, exercise 4 in the book. Assume that x and y are two differentiable functions of variable t, which means we are going to differentiate with respect to t. So let y is square root of x, dx over dt is given as 3, so x prime is given as 3, x is given as 4, find dy over dt, find y prime. So we first differentiate the given function. What is y? Derivative of y with respect to t, it is y prime, or dy over dt, right? Equals, what is derivative of square root of x? Derivative of inside, x prime, divided by 2 square root of x. Or you can say dx over dt divided by 2 square root of x. Since writing this over and over again, it takes time and annoying, I'll just use primes, okay? So I don't know what y prime is dy over dt is. This is the question. So dy is equal to x prime, which is given in the question as 3. Just insert 3 for it, divided by 2 square root of x, which is given in the question as 4. So square root 4 is 2, 2 times 2, 4, so it is 3 over 4. See, it's pretty simple. Everything necessary in the question will be given. There will be just one unknown. When you differentiate the given function, you will isolate that unknown by using the given information. So everything will be given, just like differentiating at a point. we will be given every necessary information in the question. So there will be just one unknown. We'll isolate that unknown. Another exercise question. We are going to differentiate it with respect to t. We have x and y. The variables are different, so we will have x prime and y prime, right? Derivative of x squared is 2x, x prime. Derivative of y squared is 2y, y prime. Derivative of 25 is 0. Keep in mind that x prime means dx over dt, y prime means dy over dt. What is given in the question? Dx over dt, x prime is given as 8, x is given as 3, and y is given as 4, y prime is missing. So see how easy the equation is. 2 times x, which is 3, times x prime, which is 8, plus 2 by y, which is 4, by y prime, which is unknown, equals 0. So it is basic math, just solving the equation. 2 times 3, 6 times 4, 8, 48, 6 times 8, 48, plus 8 y prime equals 0. Bring 8y prime to the other side. Y prime will be negative 6. That's it. Another question. We have a ministry question, and we have a similar exercise question like that. It gave us this function x, y being equal to 15. We are given y prime. We are asked to find x prime. We are given x. We know y prime. We know x. We don't know x prime. And we don't know y. But we will need it, right? When we differentiate this, we will need y. So we should find y first. So how do you find y? When you know x in this equation, you can find y easily. Xy equals 15. X is given as 5. 5y equals 15. Then y is equal to 3. Okay, now we got only one unknown. We can solve the question. Let's solve it. Let's differentiate this product. Derivative of first, x prime, times second, plus first times derivative of second equals 0. So let's substitute the given. X prime is unknown. It's unknown, we don't know. Y is, we found it as 3, plus x, it's given as 5, times y prime is given as negative 3, equals 0. See, we got everything necessary to solve this question. There's just one unknown, which is x prime. 5 times negative 3, negative 15. 3x prime is 15. When you move it to the other side, divide by 3, x prime will be 5. So x prime means dx over dt. Okay, another exercise question. A particle moves on the graph of the function y equals sine x. Find dy over dt. Find y prime. When x is this, and x prime is this. So let's differentiate this function first. Derivative of y, since it's with respect to t, we will have y prime and x prime both. So y prime equals derivative of sine is derivative of the angle multiplied by cosine of the same angle. Now insert the given. Y prime is not given. This is what the question is. X prime, yes, it is given as 2 multiplied by cosine. X is also given as pi over 6. So we don't need y in this question. So this is how we find the answer. There is no y in the differential derivative. So what is cosine pi over 6? Cosine 30 square root 3 over 2. This is square root 3 over 2. 2's will cancel. The answer is square root of 3. Alright. One last question. Another ministry question. Assume that x and this is this sentence. You'll see the sentence in every question. This is your function. Read the given. dy over dt, y prime is given. dx over dt is unknown. X prime is unknown. and y is given, x is also unknown. So let's differentiate this function. Derivative of y with respect to t is y prime equals derivative of this square root is derivative of the inside, which is negative x prime divided by 2 square root of 2 minus x. Now let's substitute the given. Y prime is given as negative 4. Write negative 4 instead. Equals x prime is unknown. We don't know. It has negative in front. 2. What about square root 2 minus x? Do we know what x is? We don't know. Do we need it? Actually, we do not need it. We already know the value of y. What is y? Y is square root 2 minus x. So in place of square root 2 minus x, we can directly write 3 without finding x. So here, in place of square root 2 minus x, so just write 3, it's already given. So no need to make it complicated by finding x. It is not necessary. We don't need x, we need y. We need the whole thing here. This whole thing is y, which is 3 in the question. So now, let's isolate x prime. Negative 4 by 2 by 3, 6. 6 by negative 4, negative 24. So x prime will be 20, positive 24. Right? It's such a nice question.